Okay, today we're going to be in Math Mammoth 6A on starting on page 68. And we're going to be looking at scaling figures 1. Alright, so first of all, when we talk about scaling a figure, we're talking about increasing or decreasing a shape in size while maintaining all of the proportions. Now that means that we're just making the shape larger or smaller but keeping the same shape. So let's look at an example. Alright, let's say we have this triangle. Alright, and let's say that this side is 3, this side is 4, and this side is 5. Alright, now if we make another triangle that's the same shape, alright, and we use a scale factor of 1 to 2, that means that the first triangle has a factor of 1 and the second triangle has a factor of 2 compared to the first triangle. In other words, every side of the second triangle is twice as much as the first triangle. Alright, so this side right here is twice as big as this side, so it's going to be 6. And then the bottom of the triangle is twice as big as this bottom, so that'll be 8. And then this side right here that's kind of slanted down, almost like a diagonal, on the big triangle will be 10. So each time, to get the side of the big triangle, I had to multiply the little triangle side by 2. Alright, so 3 times 2 gave me 6, 4 times 2 gave me 8, and 5 times 2 gave me 10. Alright, so this triangle, small triangle to big, had a scale factor of 1 to 2. Now, one of the things that's important is to understand that, let me draw another triangle. Alright, and we're going to draw a bigger one again. Okay, now let's say I give you some sides, like I tell you that this is 4 and this is 6, and let's just say that I tell you that, let me see, and I tell you that this is 7, okay, and I don't tell you any other information. Alright, so, and let's say I tell you that these two triangles are similar, that means they have the same shape. Can you tell me what the scale ratio is? Well, the scale ratio of the small triangle to the large would be, I have to find two sides, one on the small, one on the large, that correspond to each other. In other words, they're kind of like the same side even though they're different lengths. Alright, so on the little triangle, this side is the same, it corresponds to this side on the big triangle. Alright, so I'm going to use the two numbers of the two corresponding sides to get my scale ratio. So that would be 4 to 6. Alright, and that can be reduced to lowest terms or simplest form if I divide both of those numbers by 2, I'll get 2 to 3. So we would say that the scale ratio for those two triangles is 2 to 3. We don't use the number 7 because we don't have another corresponding side down here. We don't know what this is, so we can't really use that side. We had to use the other side to get our scale ratio. You can use any of the sides as long as you have the measure in both triangles of that same corresponding side. Alright, so now let's talk a little bit more about corresponding sides. Let's say I have this little triangle right here. Okay, and I have another triangle, and it's drawn this way. Okay, and I tell you that those are similar. Alright, so now this is a little trickier. You have to really think. But let's say I tell you to find the side that corresponds to this side on the big triangle. Well, the big triangle is flipped around, but I still can find the side that corresponds to that side. It would be this one. Okay? Now, which side corresponds to this side? Well, it's that side, right? Okay, and then this bottom side then corresponds to the bottom side. So you have to look at the shape of the triangle, and sometimes you might have to flip it around to find the sides that correspond to each other. Okay? Alright, so if we have some figures like this and we want to find the scale ratio, and let's say that they don't give us any numbers, they tell us to measure the lengths of the sides to find the scale ratio. Well, to find the scale ratio, you need the measure of two of the corresponding sides. So on these two triangles, you could measure the two purple lines, or you could measure the two blue lines, or you could measure the two red lines. It doesn't matter, but you just need to find two sides that correspond to each other. Okay, so let's say that we're going to measure the blue lines. Alright, so you would measure the blue line for the small triangle, and let's say you got 7 millimeters. Okay, and then let's say you measured the blue line for the big triangle, and let's say you got 12 millimeters. Alright, so now to find the scale ratio, since you have the measures of two corresponding sides, you just write those measures down. There's your scale ratio, and you try to reduce it if possible, but in this case you can't reduce it, so that's your answer. Okay, now what if I tell you to draw a copy of, let me do this triangle right here. Alright, and I'm going to make this 3, 4, and 5. Okay, and I want you to draw a copy of that triangle using a scale ratio of 1 to 1.5. Okay, so now what I need to do is I need to draw a triangle that has a scale ratio of 1 to 1.5, so it's going to have the same shape, but my corresponding sides are going to be 1.5 times the original triangle. So to get this side, I'll have to multiply 3 times 1.5. Alright, so 3 times 1.5 is going to be 15, 4.5. So this side right here will be 4.5. Alright, and then to get this side, I have to multiply 5 times 1.5. Do 1.5 times 5. Okay, so that's 7.5. And then the bottom side is going to be 4 times 1.5. So 4 times 1.5 will end up being 6. Okay, now if they ask you to draw it, then you'll have to draw a triangle that is 6, whatever the unit is, millimeters or centimeters or whatever, by 4.5 by 7.5, okay? So use your ruler to be able to draw that out. Now, if they give you a problem where they give you a shape and they say, draw a copy of this triangle using a scale of, let's say, 1 to 3, okay, and they don't give you any numbers, then you're going to have to measure these sides first. Alright, so let's say you measure those, and let's say you get 6 millimeters here, and let's say you get looks like about maybe 9 millimeters there, and let's say you get 10 millimeters here. Alright, well then, to draw a triangle that has this scale ratio, you're going to have to multiply every number by 3. Alright, so you will have to draw a triangle that has, this side will have to be 18 millimeters. This side will have to be 9 times 3, 27 millimeters. And then this side will have to be 10 times 3, or 30 millimeters. Okay? So that's the kind of problems that you have on page, what page is that? That is page 69. Okay? Now, if they tell you to have a scale ratio of, let's do another example. Let's say I have a triangle, and I have, let's say, 4, 8, and 12 millimeters when I measure. And I want to draw a triangle that has a scale ratio of 4 to 1. Okay, now I'm going down by a factor of 4. So now each one of my measures of my new triangle is going to be divided by 4, because the first triangle, which is my original one, is 4 times as much as the one I'm drawing. So each one of the sides of the new triangle is going to be the original triangle divided by 4. So that'll be a 1. And then this one divided by 4 is 2. This one divided by 4 is 3. Okay, so 4 to 1 means 4 to 1. Okay, or 8 to 2, which is 4 to 1, if you reduce it, or 12 to 3, which is also 4 to 1. Okay. Now, let's just say that you have, let's look at the example on the top of page 70. And there we have two rectangles. One of them is a small rectangle. One of them is a larger rectangle. So you have the small one. And they say this side is X. And then you have this larger rectangle, which is supposed to be the same shape. And this side is 3.5 meters. Alright, now we're trying to find X. And they tell us that the ratio of the lengths of the small to the large is 2 to 7. Alright, so how do we figure out what X is? Well, X is to 3.5. Alright, so these two sides, if you compare them, they should be in a ratio of 2 to 7. Alright, so now you have a proportion set up. So you should be able to solve that proportion by cross multiplying. So you would get 7 times X equals 2 times 3.5. And then if you work that out, you will find that X equals 1. Okay? So you know how to solve that proportion. So the main idea here is that whenever you have two similar figures, that you can set up a proportion. You have the corresponding sides make a ratio, and then the scale factor also makes a ratio. And you can set up a proportion with those and solve for the missing side. So when you do the problems on page 70, you can use this method. Just be sure that when you use this method, that when you make the ratio, that you write it down properly, and that you're writing down corresponding sides. In other words, in this problem, the corresponding sides were this side and this side. Okay? So you could write X is to 3.5 as 2 is to 7. Alright? So do the problems on page 70 using that method. That's all for today. Bye.